Good day to you all. My name is Ray Aizon, and we are the presenter 8 of Group 3 CE 2101. And we are here today to report about horizontal curves.
Hi, my name is Isaiah Michi Al-Anjan from Presenter 8 and I will be discussing about simple curve. Simple curve consists of a single arc of a circle connecting two straight. It has radius of the same magnitude throughout. Elements of a simple curve. PC or point of curvature, it is located at the beginning of the curve. Here. PT, point of tangency, it is located at the end of the curve. Here. PI, point of intersection, it is the intersection of both two tangent lines. Here, this is the PI. And then the radius of the circle R, here. And then tangent distance, here. Wherein, to create a simple curve, two tangent line is created, these two. Wherein, tangent line is perpendicular to the radius. Degree of curve. It is the angle of the curve wherein it is equal to the angle of intersection here, and it is equal to the angle of intersection or deflection angle. E or external distance, it is the distance from our midpoint to the point of intersection here. Middle ordinate, it is the y component of our curve. It is the distance from the midpoint to the center of our chord here. This line here is our chord. LC, length of the curve here. So sample problem 1. Refer to the figure, this figure, and information given wherein angle is equals to 12 degrees, 51 minutes, r is 400 meters, point of intersection at 0 at 241.782, calculate the station of the BC and EC. This station here and this station. For the solution, so we are required to compute for the BC, which is the PC element, point of curvature, and the EC, which is the PT element, or the point of tangency. So that means we need to figure out the back tangent length to calculate the BC element and the length of the curve to calculate for the PT. For the back tangent, C is equals to R tan angle over 2. So 400 tan 6 degrees 25 minutes 30 seconds is equals to 45.044 m. This is our T. For the length of the curve, L is equals to 2 pi r times angle over 360 degrees. 2 pi times 400 times 12.850 over 360 is equals to 89.710 meters. And then, next step, to calculate for the BC, point of intersection minus the T. So, 241.782 minus 45.044 is equals to 196.738. This is our BC. To calculate for the EC station, we need to plus 89.710 to our BC, which is 196.738 plus 889 0.710 is equals to 286.448.
Hello everyone, my name is Joan Luis P. Parsanas and I'm going to discuss about compound curves. A compound curve is two or more simple curves which have different centers, bend in the same direction, lie on the same side of their common tangent, and connect to form a continuous arc. The point where the two curves connect, namely the point at which the point of tangency of the first curve equals to the point of curvature of the second curve, is referred to as the point of compound curvature or PCC. The computation of compound curves presents two basic problems. The first is where the compound curve is to be laid out between two successive point of intersections on the preliminary traverse, and the second is where the curve is to be laid in between two successive tangents on the preliminary traverse. So here are the elements of the compound curve. The PC point of curvature is located here. The point of tangency, the point of intersection, and the point of compound curve. The T1 and T2 length of tangent of the first and second curve is located here. The vertex of the first curve and second curve is located here, above the length of tangent, and the I for the central angle of the first curve and second curve is located here beside the vertex. And the I for angle of intersection is located here, while the LC length of the first curve and second curve is located below the vertex, and the length of the first chord and second chord is located here in the middle, and the length of the long chord from PC to PT is this line here, while the T1 plus T2, the length of common tangent measured from V1 to V2 is here. So here's the sample problem for compound curve. Refer to the figure and information given. The angle is 11 degrees, 21 minutes and 35 seconds. Point of intersection at 14 at 87.33, and D is equals to 6 degrees. Calculate the station of the BC and EC. So here is the solution. The radius is 954.93 feet. To get the tangent, you need to solve this. R times tan times angle over 2. The R is 954.3, and the angle over 2 is 5.679861 degrees, which is equals to 94.98 feet. To get the length, you need to solve this. 100 times angle over D, which is equals to 100 times 11.35972 over 6, which is equals to 189.33 feet. To get the BC and EC, so here's the solution for that. Point of intersection at 14 and 87.33 minus the tangent 94.98, which the answer is 13 at 92.35. To get the EC, you need to add the length, which is 189.33, and here's the answer for EC, 15 at 81.68.
Hello
Hello, I am Danica Dolocapas, and I will be discussing reverse curves. So what is reverse curves? Reverse curve is a segment of a highway or railroad's route's horizontal alignment in which a bend to the left or right is soon followed by a curve in the opposite direction. Reverse curves are also used when the straight are parallel or intersect at a very small angle. So reverse curves are best suited for hilly terrains and highways used for relatively low-speed vehicles. They should also be avoided as far as possible on the main railway lines and highways where speed are necessarily high. Reverse curves are also being used in great success on park roads, formal paths, waterway channels, and etc. So the elements of the reverse curve. So a reverse curve is composed of two or more simple curves turning in the opposite direction. So their point of intersection lie on the opposite ends of the common tangent, and the PT of the first curve is coincident with the PC of the second. This point is called the point of reverse curvature, PRC, or as you can see on the presentation, it is located in the middle. So the other factors of the elements of reverse curves are PC, the point of curvature, PT, point of tangency, PRC, point of reverse curvature, T1, length of the tangent of the first curve, T2, length of the tangent of the second curve, V1, vertex on the first curve, V2, vertex of the second curve, I1, the central angle of the first curve, I2, central angle of the second curve, LC1 is the length of the first curve, and LC2 is the length of the second curve. So L1 is the length of the first chord, L2 length of the second chord, and lastly T1 plus T2 is equals to the length of the common tangent measured from V1 to V2. So lastly, finding the stationing of PT, there are two kinds. So the stationing of PC, which is station PT equals to station PC plus LC1 plus LC2. Then the second is the stationing of V1, which is station PT equals to the station V1 minus T1 plus LC1 plus LC2.
Hi guys, it's Ray again. What we have here is a reverse curve for non-parallel tangents. The following figure below shows an example of a reverse curve of unequal radii connecting non-parallel tangents. So these two lines, or these two tangent lines, are non-parallel because they do not have the same direction. And what we have here is a reverse curve for parallel tangents. The following figure below shows an example of a reverse curve of unequal radii connecting two parallel roads or tangents. So as we can see here, these two lines or these two tangent lines have the same direction. Thus, they are called parallel tangents. We have here a sample problem for a reverse curve. The problem states that two parallel tangents 10 meters apart are connected by a reverse curve. The chord length from PC to the PT is equals to 120 meters. We are asked to compute the length of the tangent with common direction, to determine the equal radius of the reverse curve, and lastly, to compute the stationing at the PRC if the stationing of A at the beginning of the tangent with common direction is 3 plus 420. So we need to compute the length of the tangent with common direction. Our figure shows that we have two tangents, T1 and T2, are connected by a reverse curve. The vertical height or distance of this is 10 meters. And we also have a chord length from PC to PT, which is 120 meters. From this, we can form a right triangle, which is shown here. So the length for this side is 10 meters, and the length from PC to PT is 120 meters. So we need to find for this angle, guys. But before that, we know that this angle here is the angle for our second curve. So having this, we know that this angle is I2 over 2. So we use here sine of I2 over 2 is equals to the opposite 10 meters over the hypotenuse, which is 120 meters. So to transfer sine to the other side, this will become arc sine of 10 meters over 120 meters. So calculate that, we get 4.78 degrees. And to remove this denominator of 2, we need to multiply both sides by 2. So the answer will be 9.56 degrees. So remember that our goal is to compute the length of the tangent with common direction, which is this one. And remember that we have a vertical height or distance of 10 meters connected to the extension line of our second tangent, which is this one. Thus, we can create another right triangle, which is shown here. So looking back, we know that the length for this side is 10 meters, having an angle of 9.56 degrees, and h as our unknown value or the tangent with common direction which connects V1 to V2. So how do we compute the length of the tangent with common direction? First, we use sine 9.56 degrees equals 10 meters over the unknown value of h. So this one is the value over sine 9.56 degrees equals 10 over h. So to get rid of h, we need to multiply both sides by h, which becomes h times the value of sine 9.56 degrees equals 10 meters. So how do we get h man? So we need to divide both sides by the value of sine 9.56 degrees, which then becomes h equals 60.212 meters. So now, we already know the length of the tangent with common direction, which is equals to 60.212 meters. And with that, we can get the length of both tangents by dividing h by 2, which is equals to 30.106 meters for both tangent 1 and tangent 2, as this will be needed to compute for the radius of each curve. So next, we need to determine the equal radius of the reverse curve, which happens to be r1 equals r2. And this formula is from our simple curve earlier. We just need to manipulate this formula and turn it into this one, which is radius equals the tangent line over the tangent of I2 over 2, which is equals to 30.106 meters over the tangent of 9.56 over 2. To solve that in the calculator, we get the radius of 30.3 meters, or r1 equals r2 is equals to 30.3 meters. Last but not the least, we need to compute the stationing at the PRC If the stationing of A at the beginning of the tangent with common direction is 3 plus 420, which is this one, or the stationing of A. So before we could even get our PRC, we need to know first the station at PC, which is this one. So to get our PC, we need to solve 3,420 minus the length of our tangent, which is 30.106, is equals to 3,389.894. Or PC is equals to 3 plus 389.894. We also need to compute for the length of the curve. So this one is the formula for the length of the curve, which is equals to 2 pi times 360.3 times 9.56 all over 360 degrees, which is equals to 60.072. Now we could get the stationing of the PRC just by adding the station at PC and the length of the curve, which is 3,389.894 plus 60.072, which is equals to 3,449.966, or PRC rather, is equals to 3 plus 449.966. So that is all for our report, and I hope you learned something, and see you around.